This time, I'm going to talk about Kirk Formula and the modified Kirk Formula for spread option pricing in Python. The Kirk Formula is utilized in options pricing, particularly for evaluating the value of spread options. A notable benefit is that it circumvents the computational overhead associated with Monte Carlo simulations. The Kirk Formula provides traders with an estimate of what the spread should be worth based on the inputs, helping them evaluate potential trading opportunities and manage risk more effectively. These are the formula for the original Kirk formula. C is the price of the spread option. It depends on K, and K is the strike price of the spread option. R is the risk-free interest rate, and T is the time to maturity of the option. There are two assets here. S1 is the current price of the first underlying asset. S2 is the current price of the second underlying asset. And rho is the correlation between S1 and S2. And ND1 and ND2 are the cumulative distribution functions of the standard normal distribution evaluated at D1 and D2 respectively. So D1 is calculated with this formula, and D2 is calculated with this formula. This is the formula for original Kirk formula. There are many modified Kirk formula. In this video, I used modified Kirk formula from this paper. You can see this is the paper. You can download it from internet. In that paper, there are several new formulas. You can see here we have IT. IT is an approximation of the implied volatility that takes into account its screw, which in turn depends on the XT. You see XT equal to log of S1, and there is a YT here. So in this modified Kirk formula, it calculates IT first, and then it uses IT to calculate D1 and D2. If we compare the original formula with the modified Kirk formula, when we compare, you can see the first formula, it calculates sigma between two assets based on the correlation rho. This is the same. And then we have this XT and YT. And then we will calculate IT here. This is a new formula. And you can see in this D1's formula, instead of use sigma here, we use IT. Sigma was replaced by IT. And also when we calculate D2, this sigma is replaced by IT as well. And after we calculated D1 and D2, CK will calculate it with the same formula. Okay, so in this video, we will calculate spread option price with Monte Carlo simulation first, and then use that price as final price. So, because we don't know the real price of this spread option, we just use Monte Carlo simulation to calculate that price and use it as the real price. And then we will evaluate spread option price with original Kirk formula and compare the result with the price calculated with Monte Carlo simulation. Similarly, we will use the modified Kirk formula and then compare it with the price calculated with Monte Carlo simulation. Okay, now let's go to our model. First, let's set up the initial condition. The interest rate I've set to 0.02, and for the two asset price I set to 100. So both are 100. And time to maturity I set to 0.5. For the sigma 1 I set to 0.3, sigma 2 I set to 0.2. And then I'll use this function to do the Monte Carlo simulation. And after the Monte Carlo simulation, I will draw a graph show the spread option price. And after that, I will calculate the price with the original Kirk formula. And after that, I will calculate the option price with modified Kirk formula. And I will do the comparison. For the strike price, I will use from 0 to 21. And for the correlation, I will use 0.8, 0.85, 0.9, 0.95, 0.999. Okay, now let's run our model. Because for the simulation, I use 5 million times, so it will take some time. Now we got our results. You can see here, this is the result of Monte Carlo simulation. This is the correlation, and this is the strike price. You can see the spread option price will be larger when the strike price is lower and the correlation is lower. So the surface will look like this. And then based on the price calculated with Monte Carlo simulation, we will calculate the error between the original Kirk formula with Monte Carlo simulation and the error between modified Kirk formula with Monte Carlo simulation. You can see this is the error of the original Kirk formula, shows like this, and the modified Kirk formula shows like this. You can see when the correlation is low, 0.8, it shows like this, and basically the error for modified Kirk formula is quite stable. And then you can see when the strike price keep increasing and the error of original Kirk formula decreased, because this is -1, this is minus 0.4. And when we take a look, when the correlation is 0.85, we can see similarly the error of modified Kirk formula remain stable, and you can see this original Kirk formula's error. First, it basically decreased, and then it goes over 0. When the correlation is 0.9, we can see similar behavior of this original Kirk formula and modified Kirk formula. And you can see the original Kirk formula's error also overshoot. It past 0, keep increasing. When the rho is 0.95, you can see this error of modified Kirk formula remains low and stable like this. And when the correlation is very high, 0.999, you can see the error of original Kirk formula keep increasing. You see this is very large. It's about 17.5 already. But the error of modified Kirk formula remains stable here. Of course, you can run this program again and you will get a little bit different result, but will be quite similar. In summary, you can see this modified Kirk formula gave us very stable result, not like this original Kirk formula. The error will keep increasing when the strike price is larger. This is how you can calculate spread option price with Kirk formula and modified Kirk formula. Please comment, like, and subscribe to my YouTube channel. Thank you.